Hello students, welcome to class 11 physics. In this video we are going to solve some of the numericals of the textbook exercise of chapter 5 laws of motion. Numerical number 18. Two billiard balls each of mass 0.05 kg moving in opposite directions with speed 6 meter per second collide and rebound with the same speed. That means here we are having two balls. Mass of each ball is same and both are moving in the opposite direction, that is towards each other, after which they will be colliding and it will be rebounding. That means after collision it will be moving in the opposite directions with the same speed. What is the impulse imparted to each ball due to the other? That means here we need to find the impulse, and impulse that is nothing but F into delta t. So here F delta t that is equals to delta p. This we get the equation from second law of motion, that is F equals to delta p by delta t. From this equation we can write F delta t equals to delta p. Here F delta t is impulse. So finding this change in momentum will also give us the impulse imparted to each ball. Now change in momentum, that is final momentum minus initial momentum equals to 0. So first of all we will be finding the momentum, initial momentum and the final momentum. So let us see the momentum before collision, which is considered as the initial momentum. That is P1 vector is equals to mv vector, that is product of mass and velocity. Now putting the value of mass and velocity, we get 0.05 into 6, which is equals to 0.3 kg meter per second. Momentum after collision, here P2 equals to m minus v, because now it will be moving in the opposite direction, so it will be minus mv, which is equals to minus 0.05 into 6 equals to minus 0.3 kg meter per second. Thus impulse of force of each ball, that is equals to change in momentum, that is delta p, and delta p is equals to P2 minus P1. P2 is 0.3 minus P1 is minus 0.3, which is equals to 0.6 kg meter per second. Therefore impulse of force of each ball applied in mutually opposite direction, it is equals to 0.6 kg meter per second. So students, you may note down this numerical. Now numerical number 19. A shell of mass 0.020 kg is fired by a gun of mass 100 kg. If the muzzle speed of the shell is 80 meter per second, what is the recoil speed of the gun? So here we are considering, suppose we are having a gun, from that the shell is fired by the trigger, that is by the gun. Mass of the gun, that is 100 kg, and mass of the shell, that is 0.020 kg. So when this recoil is in one of the direction, the shell will be in the opposite direction. So the directions of the motion of the object will be opposite to each other. Here the muzzle speed is given, that is 80 meter per second, and we need to find the recoil speed, that is the muzzle speed. So given over here is mass of the bullet m1, that is equals to 0.020 kg, speed of the bullet v1, that is equals to 80 meter per second, mass of the rifle, that is 100 kg, and recoil speed of the rifle, let it be v2, that we need to find. Now by law of conservation of the linear momentum, the initial momentum and the final momentum is equal, that is change in momentum will be 0. So here initial momentum that is m1 dash v1 dash plus m2 dash v2 dash. Let us consider like this, because here the velocity of the muzzle as well as the bullet both is 0, because both are at rest initially, so this whole term becomes 0. Now the final momentum, that is m1 v1 plus m2 v2. So we can write over here delta p equals to 0. Here final momentum minus initial momentum equals to 0, that is final momentum equals to initial momentum. Here we have considered final momentum equals to initial momentum is 0. Now final momentum, that is the momentum of the system consisting of the shell as well as the muzzle. So here we can write it as m1 v1 plus m2 v2 equals to 0. m1 v1 and m2 that is given, we need to find v2. So taking v2 as the subject, from these equation we can write m2 v2 equals to minus m1 v1 and v2 equals to minus m1 upon m2 into v2. So we get this equation. Now substituting the values of m1, m2 and v1, that is 0.020 upon 100 into 80. Its value is minus 0.016 meter per second. Here negative sign indicates that velocity of the rifle is in opposite direction of the bullet. So students, you may note down this numerical. Now numerical number 20. A batsman deflects a ball by an angle of 45 degree without changing its initial speed, which is equal to 54 km per hour. What is the impulse imparted to the ball? Mass of the ball is given as 0.15 kg. So here you can see that when the bat is hitting the ball, right, the ball hits the bat by making an angle 45 degree. That means here the ball is coming and the bat hits the ball by 45 degree. So this is the initial momentum and this is the final momentum, that is P2. Now from the equation we can write as P2 equals to, because here the vector is neither in x-axis nor along the y-axis, so we need to take the projections. Taking the projection along x-axis, that gives the cos theta component. So it will be P2 cos theta I cap, and taking the projection on y-axis, it will be plus P2 sin theta, because it is along y-axis, it will be j cap. So here P2 is nothing but mv, so we can write mv cos theta I cap plus mv cos theta j cap. Taking mv common, we get mv cos theta I cap plus sin theta, here it is sin theta j cap. So P2 equals to mv into, because theta over here is 45 degrees, so it is mv cos 45 I cap plus sin 45 j cap. And here you can see from the figure P1 is mv and direction is towards the negative x-axis. So here it should be minus mv I cap. So now the change in momentum is P2 minus P1. P2 that is mv into cos 45i plus sin 45j. And P1 that is minus mv I. So here minus minus becomes plus. So it will be over here, it will be plus. Now taking mv common on from both these terms, we get mv cos 45i plus sin 45j. Taking this I common, we get mv into cos 45 plus 1 I cap plus sin 45 j cap. Now putting the values of mv, cos 45 and sin 45. So we get 15 into 0.15 into bracket 0.707 plus 1 I cap plus 0.707 j cap. So its value will be 2.22 into under root of 1.707 square plus 0.707 square. So when you calculate this, we get the approximate value as 4.2 Newton. So this is the impulse imparted to ball. So student, you may note down this numerical.